Where the universe's coldest location. At about Chile minus 459 degrees Fahrenheit, the universe's coldest spot is more than 3 times icier than any site on Earth. The Boomerang Nebula, the chilliest object discovered to date, is the coldest spot in the cosmos. It is the constellation Centaurus, about 5,000 light-years from Earth. The Boomerang Nebula is a young planetary nebula with a fading red giant star at its center. It is a reflecting cloud of dust and ionized gases. It was once a star similar to our Sun, and as is normal for stars in their final phases of life, it has been shedding its outer layers. But it's been discovered that it's losing mass around 100 times more quickly than other fading stars of a similar size. And to top it off, it's doing it at a mind-blowing 100 billion times the speed of the Sun. The core star has actually lost approximately 1.5 times the mass of our Sun as a result of this over the previous 1,500 years, according to NASA. Additionally, because the gases are being released so quickly at a velocity of 164 kilometers per second or 101, a significant amount of heat energy is being blasted away. The result is a very cold region of space, which is best described by recapitulating the absolute zero temperature, which is the lowest point of the thermodynamic temperature scale. This has a Celsius temperature of minus 273 and a Fahrenheit temperature of minus 459. What about the Boomerang Nebula then? The deep interior of the Boomerang Nebula is a teeth-chattering minus 458 degrees Fahrenheit or minus 272 degrees Celsius, which means that it is only 1 degree Celsius above absolute zero. That makes it more than 3 times colder than the chilly minus 199 degrees Fahrenheit temperature measured across Dome Fuji, Antarctica in 2010, according to The Independent. When compared to the cosmic microwave background, which has a temperature of minus 454 degrees Fahrenheit from the Big Bang, the Boomerang Nebula is significantly colder. The Boomerang Nebula does, in fact, absorb light from the CMB, as was soon seen upon the nebula's initial discovery in 1980. They didn't know it at the time, but the boomerang-shaped nebula ensured it at least had a natural name when astronomers Kate Taylor and Mike Sayrot started studying in 1980 using the Anglo-Australian ground-based telescope at the Siding Spring Observatory. At least it appeared to resemble one until it was more clearly caught by the Hubble Space Telescope in 1998, which revealed a closer similarity to our hourglass or bow tie. However, astronomer Raghvendra Sahai had already been hard at work, predicted the existence of cold areas in a study published in the Astrophysical Journal in 1990, even before he was aware of this additional information. According to Sahai, when the star's wind expanded quickly as it moved outward, the temperature dropped sharply, resembling that of a cosmic refrigerator. As a result, a team led by Sahai attempted to verify the idea of the Boomerang Nebula in 1995 using the Swedish ESO sublimeter telescope in Chile, decommissioned in 2003, which resulted in the temperature being measured. Astronomers using the Atacama Large Millimeter Submillimeter Array in Chile later confirmed the temperature, but the Sahai's analysis published in the Astrophysical Journal in 2017 provided additional insight into what may have occurred. In his research, Sahai discovered that the rapid acceleration of gas was to blame for the low temperature, but he also sought to explain why the expulsion was occurring so quickly, thinking for the first time that it was a dying red giant. Sahai was employed by NASA's Jet Propulsion Laboratory in Pasadena, California, hypothesizes that a teeny companion star may have fallen into the red giant. According to a statement by the National Radio Astronomy Observatory, the only way to eject so much mass and at such extreme speeds is from the gravitational energy of two interacting stars, which would explain the puzzle's properties of the ultra-cold outflow. Because air expands and cools more quickly through a small aperture, it is also crucial that it ejects its outer layer from two tiny points. The next stage for scientists is to look for other, ever colder variations of this phenomenon. The central star of the Boomerang Nebula will eventually turn into a white dwarf.